Welcome to Primes and Composites. In this video tutorial, you will learn about prime numbers and composite numbers. As you have seen with the factors and multiples video, numbers are created by multiplying their factors together. Some numbers have more factors than others. Prime numbers have only 2 factors, while composite numbers have more than 2 factors. Prime numbers have only 2 factors. Those factors are 1 and itself. If you can only divide a number by 1 or itself, the number is considered to be prime. Here are some examples. 3 is a prime number because it can only be divided by itself or 1. 11 is a prime number as well because it too can only be divided by itself or 1. The same can be said for 7. It can only be divided by itself or 1. And finally, 17 is a prime number because it can only be divided by itself or 1. However, remember that there are an infinite number of prime numbers, and they go on forever and just keep getting bigger. Here are some examples. 2, 3, 5, 7, 11, 13, 17, and so forth. All of these numbers are prime, and these are only the lowest of the prime numbers. Please note that 2 is the only even prime number because its factors are only 1 and itself. Okay, so how do you know if a number is prime? Well, you can try to divide it by 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9. In some cases, it will be just obvious that it is prime. 17, for example, it just looks like an awkward number, and that nothing else would divide into it. It is also important to note that trial division like this can work for you, but it is very slow. Composite numbers have more than 2 factors. Most composite numbers have an even number of factors. So the factors of 12 in this example are 1, 2, 3, 4, 6, and 12. Some composite numbers have an odd number of factors, and those numbers are called perfect squares. Here are some examples. Perfect squares are the result of multiplying a factor by itself. For example, 2 times 2 equals 4, or 3 times 3 equals 9. In this case, we could write this with an exponent. 2 squared equals 4, which means 2 times 2 equals 4. Now, you have used exponents like this before when we have looked at centimeters squared or meters squared. But with numbers, it means multiplying by itself that many times. So in this case on the screen, 2 squared equals 2 times 2. You have seen this before in a times table, but you probably never even thought that much about it. Here's a times table. You'll notice that all of the squares are highlighted in yellow down the diagonal. I'm circling them here now so you can see them for sure. So 1 times 1, of course, is 1. 2 times 2 equals 4, all the way down to 2 times 12, or 12 squared, equals 144. These numbers are important because they have an odd number of factors. And here's how to explain that. Because squares are the product of multiplying a factor by itself, the number of factors a square has is odd. For example, let's take 9. 9 equals 3 squared, or 9 equals 3 times 3. So therefore, the factors of 9 are 1, 3, and 9. Even though there are 2 3's there, we only count one of them, because 1, 3 is the factor. Composite numbers. For all other composites, the number of factors will be even. For example, take the number 18. 18 equals 1 times 18, 2 times 9, and 3 times 6. Therefore, the factors of 18 are 1, 2, 3, 6, 9, and 18, which are an even number of factors. Please avoid any confusion here because the number of factors is even, regardless of whether the number itself is even. For instance, 21 has an even number of factors even though itself is an odd number. Speaking of strange numbers, let's look at the number 1. The number 1 is not prime because it does not have exactly two different factors, and the number 1 is not composite because it does not have more than two factors. The number 1 is special, it is unique, and is often misunderstood. Prime factorization trees. Prime factorization is a way of writing a composite number as the product of its prime factors. You can use a factor tree to help you work out the prime factorization. And always remember, for a prime factorization, never use 1 as 1 is not prime. Let's look at an example of a prime factorization tree. Let's start with the number 48. 48 is an even number, and we know that even numbers can be divided by 2. That is the perfect place to start. So 48 is a product of 2 multiplied by 24. We cannot break down 2 any further, but we can factor 24. And if we look, 24 is also an even number, so we know that it is divisible by 2. So we're going to carry that first 2 down from 2 times 24, and we're going to split up 24 into 2 times 12. Looking at the 12, we can see it is an even composite number again. We can divide that by 2 as well. And we need to carry down the 2 times 2 from the previous line. So we factor 12 into 2 times 6, carrying down the other 2 times 2. We look down at the 6. We see that 6 is also a even composite number, and it is divisible by 2 as well. Carrying the 3, 2 times 2 times 2, so those 3 2's down, and dividing 6 by 2, we are left with 2 times 2 times 2 times 2 times 3, which just happens to be the prime factorization of 48. 2 times 2 times 2 times 2 times 3. It is very important to note that all composite numbers can be reduced to their prime factors. And that is the end of this video tutorial on primes and composites. Do some practice at home with prime factorizations of composite numbers using the factor tree method you just learned. Good luck, and we'll see you in class.